Now we're going to look at combining this with some of the other transformations we've already used. So recall, in the previous lesson, we learned that a dilation that isn't about the origin is the same as a dilation around the origin, where we first do a translation, and then a dilation, and then a translation. Well, congruence transformations, the translation, reflection, and rotation, preserve shape. So that means that if we apply those in addition to the ones we've been using, we're still going to have similar polygons. Okay? Now we are going to be using some new notation for you. Before we've been using the little composition function, or the composition notation. It looks a lot like a degree symbol, but it's not. But you can also use parentheses, and actually parentheses is a nice way to write it. When you take Algebra 2, you're going to see functions where you have one function kind of inside, and then you work your way outside. So you actually do the innermost function first. And that's kind of like, remember order of operations? Where do you start? You start with the parentheses, so you work your way from the inside out when doing transformations. So in this example, we're going to transform triangle ABC using the reflection of the image or pre-image over the line y equals 2, which I've already drawn there for you to make it easier, and a dilation about the origin with a scale factor of 3. Which one do we do first? We start from the inside of the parentheses. So we're going to do the dilation first. And I'm going to set up a table. With dilations, it's so much easier to just multiply the coordinates when we have it around the origin. So I'm going to multiply all my coordinates by 3 and graph them. So now you can see my dilated triangle right there. Okay. Then I need to reflect that triangle over this line. When you reflect over a line, it should be the same distance across. So this one, the table, I'm going to go ahead and still use it, so I have my points. But reflection is almost easier just to count visually. So if I do this first one here, I can see I'm 7 units above the line, so now I need to go 7 units below the line. Same thing for this point, so that's -9, -5. Same thing for point B prime up here, go 7 units below the line. This one is 1, 2, 3, 4, 5, 6, is that right? 1, 2, 3, 4, 5 units below the line. So I need to go 5 units above the line. And that will land at 0, 7. So there is my triangle that's been transformed. Now there's another set of a composition of transformations that's really cool, and that is when we have a dilation and a dilation. So two dilations about the same point. So here I have the scale factor, and I'm setting my scale factor to 2 to create this one from that one. Now I'm going to do another dilation about the same point, and here I'm going to set the scale factor to 1.5, so you can see it's moved out here. Well, how could I possibly create a dilation? This is just one dilation. Right now the scale factor is 7. And I'm going to adjust it and bring it in so it matches. What did I get? The scale factor was 3. So what scale factor was equivalent when I used 2 and 1.5? It was 3. So the cool thing you can do, remember that dilation, when you scale factor, it's a multiplying effect. Well, what's 2 times 1.5? It's 3. So the dilation, when you have 2 of them in a row around the same point, you have a nice shortcut where you just use the product of the 2 scale factors. So here I don't even have to give you a graph. I'm going to be doing a dilation about the origin with scale factor 3 and 2. The 2 comes first. But I can actually shorten that to just a dilation around the origin with a scale factor of 6, because 2 times 3 is 6. So normally I would just say, okay, I'm going to take x and y and multiply both coordinates. Well, 1 and 2, because I'm looking at point A, would be 6 and 12. And that's your answer. So for further reflection, what makes a transformation a similarity transformation? What makes it a congruence transformation? By the way, if something's congruent, it's still similar. And how do you know which transformation to do first? Remember, please excuse my dear Aunt Sally. And finally, what is a shortcut for 2 dilations conducted around the same point?